Ever since humanity realized that Mars is a world with plenty of similarities to our own, our collective imagination has run wild about the prospect of life there, including the prospect of experiencing our lives there. Can we, as a species, colonize Mars? And if so, how would we do it? There seems to be more and more talk in the media about this subject, but are we really at a technological level where we could create a settlement on Mars?
I'm Alex McColgan, and you're listening to the Astrum podcast. Together, we will be exploring the prospect of having a human colony on the Red Planet, and we'll look at the many challenges that astronauts will face trying to make a home there.
As you may already know, Mars has had several robotic exploration missions over the years, such as the legendary Curiosity and Opportunity rovers. The journey they went on and the things they discovered has helped spur a collective interest about the future prospects of Mars. In fact, there is now so much interest in Mars that private companies have been created to promote its colonization, such as the Mars Society and Mars One. All this fascination is understandable since our neighbouring planet has a series of characteristics that make it similar to our home. It is the closest celestial body where life could have existed in the past. This notion has been around since as early as the 19th century, when astronomers began to attribute the geology of Mars to a Martian civilization. This wasn't a crazy assumption considering the technology we had at the time. A newspaper article from the New York Times in 1911 even spent time discussing the subject. However, recently, the idea of life on Mars is getting more proponents again. Even NASA believe there is something to be found. The main objective of the Perseverance rover that will launch this summer is to find evidence of life there. This is significant because apart from the Viking program in the 70s, most other missions didn't have any means of searching for biological life. Rather, they focused on the past prospects of habitability on Mars. In other words, they searched for signs of past liquid oceans and not for evidence of microbes. All these missions have been laying the foundation for what is coming up. Numerous space agencies and companies now have their eyes set on putting colonies on Mars. But how would colonists get there and survive? The trip itself to Mars would take about 3 months with the most optimal launch conditions. This doesn't seem too excessive. It's like a long voyage on a cruise ship. But you have to consider that you would spend at least 3 months outside the safety of Earth's magnetic field. Out here, you are exposed to the solar wind and cosmic radiation. Prolonged exposure to this kind of radiation can cause astronauts to develop cancer and even symptoms of Alzheimer's before they reach Mars. Fortunately, there are some thoughts about how to protect against this. The astronauts could be shielded using materials in the ship's construction that are rich in hydrogen. In fact, the cabin could be surrounded by a water tank in the walls, water being rich in hydrogen. Another option is to create a magnetic field around the spacecraft, but this requires generating a huge amount of energy from a reactor small enough to fit on the ship, something we don't have the technology to do safely just yet. In addition, the further away from Earth you travel, the longer the time delay gets with communications. We take it for granted that on Earth, if you phone someone on the other side of the planet, you might only get a split-second time delay. At these distances, the speed of light is incredibly fast. With astronomical distances, it's pretty slow. On Mars itself, the distance to Earth means the transmissions will be delayed by anything between 3 to 22 minutes. This is only one way, so accounting for the return transmission, the minimum delay is 6 minutes, making a normal phone conversation highly impractical. Text, audio, and video messages are possible, but Martian settlers will have to fend for themselves if they need to make any immediate decisions, for example in cases of emergencies or equipment failures, making remote operations or assistance in real time unfeasible. But let's say all these difficulties are overcome and that the colonists reach Mars. Where would they settle? At the moment, there is no one favourite candidate. The North Pole is a distinct possibility due to the presence of water ice in the caps there. Another interesting option is the 81 km wide Korolev crater, as it's also filled with water ice. The atmosphere isn't thick enough for liquid water to pool on the surface of Mars for any lengthy period of time. However, pockets of water locked up in ice can be found at the bottom of craters where it is cold enough. On Mars, there is also the possibility of settling near underground water deposits found in permafrost under the crust. Studies based on data from a combination of Mars orbiters have revealed and mapped out locations for water under the ground all across the planet. Although more difficult to extract than surface ice, it could open the door to colonies in more equatorial latitudes, regions that are much warmer, where solar panels for energy production would be much more effective. Mission planners would probably try to combine this finding with a location in the northern hemisphere. The ground elevation there is much lower, meaning the atmosphere is thicker, perfect for slowing and landing a spacecraft. Another consideration when looking for a settlement location is to see if there are lava tubes nearby. A lava tube is basically a long cave that formed when magma flowed through it, that has since emptied, resulting in fairly uniform tunnels. We see many examples of these on Earth, and on Mars they could even be large enough to house buildings inside. While lava tubes and caves have been identified on Mars, suitable candidates will also need to consider what we mentioned before: the elevation of the location and the prospects of nearby water. Once a site has been chosen, missions can begin to make the area suitable for a human habitat. Not everything colonists could possibly need would fit in one spaceship to Mars, so several Forerunner missions will have to take place, laying the foundations autonomously for what the colonists will need. There have been several architectural competitions to find the best design for long-lasting habitats, although there is no model that is said to be definitive yet. There are a wide variety of proposals, from creating habitats using ice to habitats built with the design structure of fungi. However, the majority of the suggestions utilize the regolith found all over the surface of Mars to build a habitat using 3D printing techniques through autonomous robots. Unfortunately, robots like these don't exist yet, so they have to be developed before this idea even becomes a possibility. But basically, this concept requires excavating material from the surface, which would then be processed and mixed with water ice into something similar to concrete. The structure is then 3D printed layer by layer by the autonomous robots. Robotic assistance and artificial intelligence will be invaluable in preparing the habitat for the colonists' arrival. Doing it by hand once they are there would be an impossible task, since astronauts are confined to their suits, especially things requiring hard and prolonged manual labor. Once the 3D printed habitat is complete, it needs to support the weight of additional regolith. These habitats must efficiently protect the inhabitants from radiation, so in the final phase of many of these proposals, they recommend covering the habitat with more regolith, simply by shoveling it on top. This is because Mars does not have a magnetic field like Earth, so radiation is a big problem on the surface too. So, the more material there is between the Sun and the colonists, the better they will be protected from its harsh radiation. Once the habitats are suitably prepared for humans, the colonists can begin to arrive. Even with the help of the autonomous robots, they still have a lot to do. Connect up power, set up equipment, just generally get the site up and running. While this is going on, they probably have to reside in temporary habitats, be it their own ship that they arrived with, or maybe inflatable habitats. In any case, these habitats would not be very spacious and only provide the basics for survival. When the permanent habitats are ready, they will need to be pressurized. One method for creating breathable air is acquiring oxygen through electrolysis, and then mix it with nitrogen. Electrolysis has the added benefit of generating hydrogen, which can then be refined into hydrazine as fuel. Once generated, this pressurized environment can easily be sustained through air recycling systems, something that is already being used by the International Space Station. Another method to get oxygen is from the carbon dioxide already in the atmosphere. That's why the Perseverance rover also incorporates the MOXIE module, which is an experiment to see if this is possible. However, for these tasks, substantial energy production is needed. One obvious source of energy is solar panels. On Mars, however, solar production is only about 40% of what you would get with the same solar panels on Earth, because Mars is further away from the Sun and receives less light. So, it's a source that is helpful only half the time due to the day and night cycle, not to mention the sandstorms that sweep across the planet from time to time that have ruined solar-paneled Martian missions in the past. So this by itself isn't reliable enough for a colony. Another option is to send a not yet invented cold nuclear reactor, which will guarantee a more stable energy source. Obviously, the best solution incorporates a hybrid of both, combined with reliable batteries to store power in the event of power outages or emergencies. The settlers would also need to consider the need to produce and purify water for consumption and other purposes. Ideally, they will be able to generate 5 litres per settler per day. This shouldn't be too much of a problem, because we know where to find water already on Mars in the form of water ice. Additionally, the colonies should also incorporate water recycling systems to minimize water waste. This technology, again, is already used effectively on the International Space Station. The production of water is as simple as extracting the ice, cooking it in an oven until it evaporates, condensing it in water, and filtering it again using ceramic and carbon filters. With these steps combined, we have all the ingredients necessary to create a habitat suitable for life, an enclosed, protected environment with a steady production of oxygen and water. From there, the colonists can focus on growing plants for consumption, but there is a big obstacle to overcome first. Although there is soil in the form of regolith on Mars, it has to be treated in order to be fertile. This regolith contains perchlorates, which are toxic for human consumption in large quantities, so it first has to be washed out with water. Once cleansed of toxic substances, the regolith needs to be treated with fertilizers, and even after this, the soil must be mixed with organic matter so that it has the ideal texture for seeds to sprout. A study already shows that it should be possible to grow plants on Mars and the Moon. But there is another option, aquaponics, or the growing of plants in direct contact with water in a closed cycle. With this environment, there is a fish pond, which is responsible for delivering nitrates to the water with fish feces. Tilapias are the most widely used fish for these closed systems, as they feed on almost anything and survive well in murky water. They are also edible, so they could be an important source of protein for the colonists. Human feces and other waste could also be used as fertilizer, since in these colonies everything will have to be reused. So, just like with the energy production, perhaps it would be wisest to use both systems, aquaponics and regolith. In any case, these farms will consume a lot of energy in the form of light, and they would need daily maintenance by the colonists. With all these systems, the colony would be self-sufficient, although it would not be an easy life. Confined to a small space, stuck with the same people, often eating the same things, and with constant tasks and stress, the psychological demands would be very taxing. Even on Earth, we have some very remote and lonely places where people live, for instance scientists in Antarctica or submarine crews. These groups undergo regular psychological checks to protect their mental health, and even in these situations, people there know that they can always be sent back home. But colonists on Mars are trapped. There's no immediate turning back, if ever, so only individuals with a strong mental fortitude could persevere. In addition, there is an array of health problems associated with low gravity. The zero-gravity experiment with the Kelly twins on the ISS brought up serious health issues that include loss of muscle and bone mass, vision problems, poor fluid distribution, a loss of balance sense, spine misalignment, cardiovascular problems, and a weaker immune system. While we don't know exactly how the human body will cope in a low gravity environment for extended periods, settlers on Mars may struggle with some of these issues too. To counteract the risks, the settlers will have to do a lot of exercise, which further lengthens their working hours. NASA has even gone as far as to consider genetic modifications for the astronauts who embark on long-stay missions to combat the dangers of radiation and microgravity, among others. This could even be plausible with current technology, although a lot of controversy on the moral limits of such manipulation arises. Still, even with all these considerations, there's no shortage of volunteers wanting to go. Every time there's been an opportunity, agencies and companies have received a barrage of applications from hopeful candidates. These colonies will depend on how technology evolves here. Although at the moment it seems that we already have a lot, but not all of what is necessary to create bases outside of Earth.
Perhaps within our lifetime, there really will be colonies on Mars. Well, that's all we have time for today. I hope you've enjoyed listening to this podcast on the colonization of Mars. If you like what you've heard, please feel free to follow us for more podcasts on other fascinating space topics. But for now, I'm Alex McColgan, and this has been Astrum. All the best, and see you next time.